Hey everyone, welcome to Miss Gilliam's math YouTube. If you are on Team Patriots, I hope this video helps you with what we covered in class today. And if you are just looking for a great video to have a better understanding of equivalent ratios, I hope this helps. So let's get started. So first I want to start with a basic ratio of 1 to 3. But I also want to tell you that this type of ratio that I am looking at is not a part to whole, but a part to part. And a part to part ratio means that part of this strip is going to be one color and part of it is going to be another color. So let's say that our two colors are going to be blue and red. So I'm going to color my 1 of this ratio blue and then 3 red. So I could say this as, for every 1 blue, I will have 3 red. So let's color this now. So if I have 1 blue, this is 3 red. Now I've added more to our pattern, and we need to continue the pattern because I still want my ratio to be equivalent to the 1 to 3. So if my goal is to keep it equivalent for the 1 to 3 ratio. So to do that, I'm going to color in the blocks the exact same way, or the squares, the exact same way I colored in the top row. And what you should see is your 1 to 3 pattern is here, and your 1 to 3 pattern is here. But I also want you to look at this as an entire amount together. If I looked at all of this together, what ratio could I write? Well, you should be able to see that you can write a 2, because now you have 2 blue and you have 6 red. And I want you to think about that. How did that happen? How did I go from the 1 to 3 to 2 to 6 mathematically? Pause the video and think about it and then come back. Okay? So you should think, oh, 1 times 2 is 2, and 3 times 2 is 6. So that made an equivalent form of 1 to 3, because I could simplify it and go backwards this direction by dividing by 2. So they are equivalent forms of one another. Okay, let's look at another visual example of equivalent ratios. Okay, now I've added another row to our pattern. So once again, I have to complete the pattern of 1 to 3. And then I want to look. Okay, so this row was 1 to 3. This next row was 2. If I'm looking at the entire thing all together, these 2 rows right here were the 2 to 6. And then now we want to look at this whole picture again. We can see that I have 3 to 9. So what this is saying is they are all equivalent. And you're probably thinking, well, I can't multiply anything times 2 to get to 3. But you need to go back to the original. Go to your original. They are all equivalent as long as they simplify to the original ratio, or down to the simplest ratio. So once again, times 3, because now I have 1, 2, 3 rows. So I'm multiplying them both by 3, and now I have, 3, not 2. And now I have 3 to 9. So right now we have 1 to 3 as 2 to 6, and 3 to 9 are all equivalent ratios to one another. Okay, I have our 3 to 9 ratio because I've continued the pattern 3 times. We have another blank row, so we're going to continue the pattern again of 1 to 3. So let's review real quick all of the patterns, all the ratios we've come up with. So on this first row was our 1 to 3. That was our original ratio. So then we're going to look at these 2 rows together. We decided was 2 to 6. And then we're going to look at these 3 rows together, and we decided that that was 3 to 9. So now I want you to pause the video, and I want you to think, what is the ratio of all of this, the entire box together? Okay, and if you've unpaused, you should have seen, okay, I have 4 blue, 2, 12 reds. So now we're looking, we have 1 to 3, 2 to 6, 3 to 9, and 4 to 12 as all equivalent ratios. Let's take a closer look at how the math works out for the ratio of 1 to 3 being equivalent to 4 to 12. And hopefully some of you are starting to see the pattern. So if you're thinking about this, how do I get from 1 to 4 mathematically? And I know some people are like, oh, just add 3. But if I add 3 to this side, do I get the 12? No. So what we're looking for is what works for both sides of the ratio. Well, if I multiply this by 4 and I multiply this by 4, it creates an equivalent ratio. So ratios are exactly, when you're trying to find equivalent ratios, they are exactly like trying to find equivalent fractions that you learned about in 4th and 5th grade. Now we can take our pattern and put it into a table that helps us organize these equivalent ratios. So we notice for 1, there was 3. When there were 2 blues, there were 6 reds. When there were 3 blues, there was 9 reds. And when there were 4 blues, there were 12 reds. And I'm sure some of you have already noticed, oh, the blue side is adding by 1 and the red side is adding by 3, and that continues down like a pattern. That's when you're thinking additively. You're looking at it as addition. And that's actually where the saying comes for every 1 blue, there is 3 reds that I have talked about in class, which is your ratio sentence. But I want you to look at this as more than just additive. I also want you to look at it as multiplicative. How can I get this from the 3 to the 12 or from the 1 to the 4 without continuing the pattern? Because sometimes you're not going to be able to continue the pattern. So you should be thinking, oh, times 4, times 4. Because sometimes you're going to be given a number that you're not going to want to draw the pattern. So let's say you were given 20. You don't want to count 5, 6, 7 all the way down to 20 in your table. So that's when you can use your pattern. And you can go from any point in your table to get to that 20. You may just decide to do from 1 to the 20 is times 20. So that means for the red, I got to take this 3 and times it by 20. So 3 times 20 gives me the 60. So 20 to 60. Okay, I want you to try to do this problem on your own first. So if I have the original ratio is 2 to 5, what would need to be in the blank to make it equivalent if it's blank to 10? So pause the video, figure out the answer, and then unpause. Okay, hopefully you've thought about it, and hopefully you've thought, okay, how do I get from 5 to 10? Miss Gilliam said we're not adding, we are multiplying. So this is multiply by 2, and then that means I would need to multiply this side by 2, which gives me 4. So 2 to 5 is equivalent to 4 to 10. Okay, let's try one more before wrapping up the video. So the original ratio in this problem is going to be 6 to 8. I want to know, how can I write an equivalent ratio if I have 18? And what would need to go in this blank to make it equivalent to 6 to 8? So pause the video, think about it, and then come back. Okay, hopefully you've paused the video and you've thought, okay, how do I get from 6 to 18? I multiply by 3. Okay, so that means I need to multiply my 8 by 3. So I would have to put 24 in the blank. Great job today, everyone. I hope this really helped you understand equivalent ratios and why we are looking at it as multiplicative and not just additive. And I hope you use those ratio tables to help you solve problems. If you are in my class, remember we are going to be talking about equivalent ratios the rest of this week. So if you're still struggling, there'll be another video tomorrow probably. And if you are not in my class and there's a concept that you would love for me to make a video of, just let me know. I can make a video pretty quick and have it posted for you. Just leave it in the comments. Have a great day.